Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. So today I'm going to present the from subject network performance modeling, autumn paper 1, and the title of the subject is TCP Performance. My name is Izhar bin Ibrahim, and this is my student's ID. So we start with the introduction of the TCP. TCP is a transfer layer protocol. Is the one of the transport layer protocol, and the other one called UDP. UDP is stand for User Datagram Protocol. Challenging of TCP performance become trickier with the new internet device such as fiber optic, router, access point, and Cat6 cable. Performance of TCP used to associate with the error control or congestion of the packets. TCP has capability to support intent of TCP characters such as unicast protocol connection states, full duplex, reliable, and streaming will make TCP is the best transfer protocol to use with. So here we have issue with the TCP. Actually there's a lot of issue coming from the TCP, but the one that I present here is a common thing happen on the TCP. The first one is packet loss. Packet loss happen when one or more packet travel over the network and fail to reach the destination. Some of reason of packet loss is including signal degradation over the network, packet drop due to channel congesting, and corrupt packet. Second one is latency or round trip time, or we call it RTT. RTT is when amount of packet is sending to receiver and it return back. This is where latency is or RTT are happening. And the third one is buffer or windows size. Windows buffer and window size need to verifying that the amount of data will keep in buffer through the kernel. The bigger size of windows, the more data can fly between two hosts. So to overcome the issue of the TCP, there's a few suggesting that I create a few suggesting that I found to make sure the to get the TCP issue. Probably we can solve the issue with a few suggesting that I list here or from my research. For the packet loss can be avoided if the layer 1 or physical was organized in proper way. So all cabling or fiber need to be arranged in proper way. So so packet loss is related with the hardware and layer 1. Second one is avoid duplex mismatch between server and IC and router or switches. Buffer overflow could cause of packet loss. Do upgrade or change the network hardware if performance drop and the issue keep happening. So most of the time packet loss is because the capability of the hardware itself. For RTT, how to reduce issue in RTT? Most of operation in RTT consists of HTTP request and response from client. The first one is to minimize DNS lookup. DNS server normally has cache name, IP mapping from authorized server. However, if cache DNS is expired and the request keeps searching and unable to resolve, which is further to add latency. For example, one of the development software, they need to use DNS for the name dev.test.com. For example, instead of to use that, we can park or we can use the from existing DNS to www.test.com/dev. It is will reduce the DNS lookup, so there's not For the searching, for the client to search that particular DNS name will be more faster than we use the current one, unless they have a technical reason to use new DNS name. Second one is minimize redirect. Minimize HTTP redirect one of the URL to other will reduce time in RTT and wait time for users. The third one, we can use RTT formula, as you can see from the slide. For example, last packet was sent in at time 4:30 and acknowledge a record at 4:37. So we use the formula, and we can get answer how much the difference between new and the old RTT. So for example, here we get 7 minutes per second. For Windows, the buffer size, I just like what to know that the bigger size of Windows, the more data can pass through the network of the route. However, the network card does not know what type of data are coming in, regardless of speed of card 1 GB or 10 GB. The only job the network card doing is to throw the packet to the link until normal packet to send. For example, Windows size 4 Mbps, and TCP will pass 4 Mbps to data network card, and network card will be send data to the link 10 Gbps. So as you can see from picture here, there's two servers. There's two servers from different location. So if the bigger Windows that we provide, so it's going to be more data will be passed through the over the network. So from summary that so TCP issue can avoid if the network infrastructure was designed in proper way. This is the first one. Second one, before we have to analyze for each of aspect, including amount of user, application involved, size of bandwidth, and capability of network hardware to handle the busy traffic. I mean, before we create one of a design of the network infrastructure, we have to analyze all those aspects. So solution from application team to avoid slowness or congestion from application itself. So application team need to think how good architecture of the application, and what happen if the application being hit at the peak time, for example. So what other solution? Maybe they can use load balancer instance to avoid the congestion of the heat from the user. So for topic today, what discover, I bring the introduction of TCP. So issue with TCP, there's a 3.1, and TCP performance tip, which is a solution for the issue, and the last one is summary. So today I think that's all my presentation. Thank you.